Hello. Today I'm going to touch on the topic of mole. What is mole concept? What do we mean by mole? Here, first of all, see, when we started with the study of science, we studied about the mass of substances being expressed in grams, kilograms, or the volume being expressed in liters, milliliters, meter cube, or time being expressed in seconds. Now, what are these gram, kilogram, liters, seconds, meter cube? These are just standards which are used to compare the mass, the volume, or the time. Here we say, okay, this much quantity is what we will call as gram. And we compare the other substances with respect to that standard value. Same way, we have mole concept, which is being used to compare different substances, whether in the form of a solid, liquid, or a gas. If we define, and definition is something you'll get in most of the books, and it says 1 mole is that weight of the substance which contains the same number of particles as are present in 1/12 of carbon-12 isotope. Now that becomes quite confusing, number of particles, carbon-12 isotope. So let me break it down for you in simple layman language. What is mole? When I am talking in terms of mass, when I say 1 mole of a substance, I simply mean the mass of that substance equal to its gram molecular mass. That is what we say as GMM, gram molecular mass of a substance. Or if the substance is in the atomic form, then the atomic mass of that substance. So, when I say 1 mole of sodium, so 1 mole of sodium would simply mean 23 grams of sodium. As simple as that. If I say 1 mole of sodium chloride, NaCl, I would simply mean 58.5 grams of sodium chloride, that is equal to its gram molecular mass, the molecular mass expressed in grams. If I have a substance in the form of a gas, then mole simply means the volume of that gas under conditions of standard temperature and pressure. If you notice over here, I have written two values, 22.7 and 22.4. There is a difference in the units of the pressure used. When you are talking about pressure in terms of bar, the volume of 1 mole is 22.7 liters, whereas if we are talking in terms of atmospheric pressure or atmospheres, then we have the volume as 22.4 liters. So if I'm talking about 1 mole of carbon dioxide, I simply mean 22.7 liters of carbon dioxide at 0 degrees and 1 bar pressure. Let us come to the third correlation, where I am correlating mole to the number of particles. So, when I say 1 mole of the substance, it simply means that it will have 6.022 into 10 to the power 23 particles. These particles can be atoms, they can be molecules, they can also be ions. We shall be talking about ions a little later. So they can be atoms, molecules, ions. As long as it says an Avogadro number, it is the value is 6.022 into 10 to the power 23 particles. So if I say 1 mole of sodium atoms, that means the mass of that would be 23 grams, whereas there will be 6.022 into 10 to the power 23 atoms of sodium in it. On the other hand, if I say 1 mole of sodium chloride, I mean to indicate that I am talking about 58.5 grams of sodium chloride, and the number of particles of sodium chloride would be 6.022 into 10 to the power 23. So there will be 6.022 into 10 to the power 23 sodium ions, and the same number of chloride ions in the particular sample of the substance. Our next step would be to be able to use this in solving the numericals based on it, because that is where the students face most of the problem. We shall simply correlate it and bring it down to a simple formula which will help us to solve the mathematical problems related to mole.